All right, we're going to talk about properties of exponents. And I'm not going to go into depth in terms of what an exponent is, but here's a quick little review. Like 2 to the third power, the base is 2. The exponent part is 3. The base tells you what you're going to multiply. The exponent tells you how many times. But what we're going to focus on now is what happens when you have like an exponent, a power, and you do something else with it. So for example, now the best way to do this is by way of example. What if I said 2 to the third, but then I multiply that by, say, 2 to the second, for example. So I'm multiplying 2 powers, right? Multiplying 2 sets of exponents. Well, if I were to do it the long way, 2 to the third, if I were to look at 2 to the third, that is 2 times 2 times 2. And then if I had another set of exponents, I would still be multiplying it, and then I'm going to have 2 times 2. So when I write it all out, I get this. Well, really, how many things do I have? How many 2's do I have? Well, I have a base of 2, and how many 2's do I have? 1, 2, 3, 4, 5. So I actually have 2 to the fifth. Now, that is how you can rewrite this thing using a property of exponents. Now, without having fancy names, let me just say, when you multiply common bases, notice that the bases are the same. When you multiply common bases, you end up just adding the exponents. So if you multiply common bases, in fact, let me go ahead and say common bases. When you multiply common bases, you add the exponents. This part right here, saying this, is what I mean by properties of exponents. So when you're multiplying common bases, you just add the exponents. And there are a number of these things. Here's another example. And this is just an introduction here. What if I had 2 to the second power, but I raised that whole thing to the third power? So I'm raising a power to a power. If I look at this, it's going to be 2 times 2, that's one set. And then 2 times 2, that's another set. And then 2 times 2, that's the third set. I did 2 to the second power 3 times. When I look at that, I actually have 2 6 times. 1, 2, 3, 4, 5, 6. So if I were to summarize that property, it would just be if you raise a power to a power, you multiply the exponents. Raising powers means you multiply the exponents. All right, and you can see how or why I would think that doing examples is the best way to go about this. What if I had, like, say, 2 to the fifth divided by 2 to the third? So I multiplied them here, now I'm dividing them. Here I'm raising them to powers. Well, if I were to write this out, 2 times 2 times 2 times 2 times 2, that's 2 to the fifth. All over 2 times 2 times 2, that's 2 to the third. Notice that whenever I have something over itself, they can cancel out, right? Leaving ones behind. So really all I have is 1 times 1 times 1, or 2 times 2 times 2, which is really just 2 times 2, all over 1 times 1 times 1, or 1. Or in other words, 2 times 2, or 2 to the second power. Now I know that that makes 4, but just to show the properties, I want to leave it like that. And you can say that when you are, if you look at it, you have a 5 and a 3, and I ended up with a 2, right? So if I have a 5 and a 3, and I end up with a 2, you can see that I actually subtracted, right? So when you are dividing powers, you need to subtract the exponents. Let me see what I can get in here. What about, and here are 2 that are just really, really unusual, and I don't have any real explanations here that won't involve some higher level math. And it's just not worth it. It doesn't really make sense. Whenever you have anything raised to the 0 power, anything, the answer is 1. All right, let me dismiss this. I see we're about to run out of time here. And whenever you have a negative exponent, it is the flip. You flip it. So it's going to be 1 over 2 to the negative, 2 to the positive 3. All right, we'll get into some more examples of all of this here in a second, but I just wanted to get them down. See, this is like 2 over 1. When you flip